अगर डेटा रियल है, आप इंटर्नशिप्स करेंगे या आप एम्प्लॉयबल बनेंगे, तब आप देखोगे जो आपको रियल डेटा मिलेगा वो ना तो कंप्लीट होता है ना वो क्लियर होता है। डेटा को क्लियर करना पड़ता है, और क्लियर करने के लिए what is the field which conditions, because data अगर dirty है, if you ever handle the data, if it is dirty or it has some holes in it, कुछ missing है, some informations are missing। अगर हमें Netflix का जो हमारा OTT प्लेटफॉर्म है उसके व्यूअर्स के बारे में कुछ जानना है और सिर्फ हम उन व्यूअर्स का डेटा ले लें जिन्होंने लगभग सारी मूवीज देखी है उस प्लेटफॉर्म में, सो वो काफी बायस्ड डेटा होगा। सो होल्स को फिल करने के लिए जो टेक्निक है उसे हम कहते हैं स्टैटिस्टिकल इम्प्यूटेशन। लेकिन जो तरीका है उन होल्स को फिल करने का, कौन सी टेक्निक लगेगी, मीन लगेगा, मीडियन लगेगा, मोड लगेगा, दैट डिपेंड्स अपॉन द domain. So one thing I'm explaining, what I want to say, I'm not saying that data science is not machine learning. What I want to convey by this slide is that it uses integrated approach. यानी दोनों को लेता है. It includes machine learning as well as statistics. So neither it's alone the machine learning, nor it's, people say that it is only statistics, it's only machine learning. It is actually an integrated approach. Okay, so fine. So it's not purely machine learning, neither it's pure statistics. So with this I can move to my second slide. Can you move on to second slide? So we believe that data science is just not analysis. Whatever we read in newspapers, that as per the analysis, people say that it's not entirely analysis. Analysis is one part. If you see the life cycle of data, there lot of effort is spent on collecting the data, cleaning the data, processing the data, storing the data, managing the data, and then comes analysis. So there's a bigger line in front of analysis. So 80% of the time it is given to other phases of the data life cycle. Only 10 to 20% time it is analysis. So if your data, you are able to collect, like Sir was telling that he has a classic collection of data. He showed us that how the Europeans, we are also, the Indian rulers are the one who are there. So he has collected a data. So I know a lot of effort, and people like you can further analyze it based on machine learning, but lot of the work depends on generation, collection, processing, storage, and managing data. And then it is visualization and interpretation. So data science is not just analysis. It has various phases, and analysis is maybe just 10 to 20%. So we'll recall that one, it is an integrated approach. Two, analysis is a part of data sciences. It is not everything. There are other things where you can try as a student. Maybe you can have your focus toward processing, collection, storage, management. Maybe you can focus towards visualization, its interpretation. So the field is open. Whether you belong to data science branch or not, there are a lot of other parts of this data life cycle where you can try your hands on. Let's go to the next slide, please. So people believe that data science, so I'm saying, is not a discipline that sits barely within STEM fields. I hope you know what is STEM fields. Science, technology, engineering, and mathematics. So data science is just not limited to STEM fields. It is multidisciplinary in nature. Even if you come from humanities, social science, library science, you all can have your contributions in data science. So it's the line I have written here, it says the lives and afterlives of data. It means how the data is replicated, how it is reproduced, how it is stored. So future generations can generate the insights from data. That's what I'm saying, where the library science pitch in, right? So how the data has to be stored in a format. So coming generations can perform the analysis on them. If you talk of humanities, if you talk of humanities or a philosopher, they would say, people say, if you torture the data, it starts speaking. Data speaks everything. But the the notion of collecting data starts lot before, when the data is given to you. So people plan that what data am I going to collect, how I am going to measure it. So there is a human judgment already into that, right? That has to be, that biasness is already there. So which data has to be collected, how it has to be measured. So there is some notions of philosophers also. There may be faculties who are coming from social science and they have maybe built up questionnaires. So how do you build a question? And that leads to analysis. We have seen tweaking in questionnaires, that the way it is asked and what percentage of result we get. So if the question is asked different way, I came across an example which came as a little over exaggerated to me, that it said that 40% of American kids are suffering from hunger. And I thought, oh, that could be, but 40% is a very high number. Then in the same article it was written that how the question was asked. It was asked from the kids that in your lifetime, any time your parents were not able to provide you the food you wanted. I think the number should have been very, very high, because the question was not asking about hunger. It was asking about what they wanted to eat. So it was tweaking. The number, what they wanted to reflect was something else. So what is being asked, it leads to the what data. So what I'm saying, that even library science, social science, philosophers, everybody has a contribution in the data science. Right? Can we go to the next slide, please? So this is not what I am saying. You all have maybe carrying your phones. You are already there. You can Google. If you Google scientists and images, you would see the figures of scientists. But if you see data scientists, I'm sorry to say, you will not see many of the names of the data science. You will see some cartoon characters or the skills. And this is one list, second list, third list, and there are numerous lists. Anybody Google? Anybody among the audience Google the skill set for data scientist or data scientist images, or who are the data scientists? This is what the output we are getting, right? So maybe so the list is very vast. I'm lucky I'm not into university. I am there, but as a teacher, I'm not appearing for exam. But for you, you would think that you have to go through this much of list to become a data scientist, right? So no, you will think that you will be more employable. अगर आप सारा कुछ जान लेंगे तो आपको लगेगा आप बहुत employable हो जाएंगे. मैं सब कुछ जान लेता हूँ. Let me go through everything. So it has computer science, entrepreneurship, arts, data management, analytics, visualization. The list is very long. So what I want to convey, maybe to the organizers, maybe to the students also, that instead of going for everything and knowing very little of anything, it's better to select anything and know everything from that, right? To select the point, whether you want to do visualization, whether you want to be part of this. So go into that. Okay, that's the entire idea. So what is the skill set for the data scientist, right? So there's a wide skill set. You can select. I agree, at certain times more skill sets may be required for some people, but not for all. To be employable, you have to select a particular skill set. I think I have last slide there. Can you just go to the next slide? Can you change the slide, please? So now I'm after complimenting what data science is not. So it is a multidisciplinary, does not just sit in the STEM field. I'm saying what data science is. This is the figure again I have taken from Google. It says tiger moms or tiger parents. They are someone who want their kids to know everything. You should know the piano, you should know the basketball, you should everything, right? So it's not, the data science is not like tiger parenting. You have to select your niche, right? So that's the, I've been given opportunity to speak as a keynote speaker. I thought, what should I speak? I thought that if few of you maybe take it as a takeaway, that you can select, you can Google that which skill set I meant for, you will be able to pick it up. So I'm saying the answer, what is data science? Is answer depends to whom do you ask. Are you asking from someone who's from computer science? Are you asking it to someone who's a mathematician, who is a statistician? So definition varies, and your role also depends. And avoid being a tiger mom when you learn this. Okay. With this, I would end it over here. If there are any questions, I'm open to it here or maybe afterwards. I think it's that's what I want to convey. There's a lot. So can you just show the previous slide? Previous. After this. After this. So if you remember, I just started my talk with, so you all can very proudly label yourself as data scientist. If you have ever handled data in any way, I know you do it. You may do financial, आप financial transactions करते हो, आप digital transactions करते हो, you maintain your database, you see what is my spending. So I could say that you can all label yourself as data scientists, and whatever your role, your work with data, so you are into broader field of the data science. So I think if I ask you all, there would be more number of audience who can raise hands that they can classify themselves as data scientists. With this, I end my talk. Thank you so much.
Thank you, ma'am, for sharing your expertise and inspiring us all with your words. Now, I would request paper ID 101 to come on the stage and be ready with your presentation with the paper title Improving Opinion Span Identification with Sentiment Analysis using Explainable AI and Machine Learning. This is by Anandaji. I would request to please come on the stage for our presentation.
So, very good morning everyone. Myself Namrata Jain. I am pursuing my BTech in Computer Science Engineering from Global Institute of Technology, and I am currently a final year student. So now let's moving forward to my research work. So my topic is improving opinion spam identification with sentiment analysis using explainable AI and some machine learning techniques. So next slide please. What is fake review? For example, we are going to buy something from e-commerce websites like Amazon, Flipkart, and we always buy something from there. So we will, it's our first choice to take out, to go through the review of a particular product. For example, if I want to buy something, I will first go for the particular product, and I will go for the reviews, that how many reviews it has been received. For example, some can be negative and some can be positives also. Where, for example, I will say, if a product has been received 500 reviews, then some of them can be, for example, 490 reviews can be of 5 rating, and 10 reviews if I am from only 1 rated. So this misbalance in review rating can lead to a customer for fake review generation. What is sentiment analysis? Sentiment analysis is a natural language processing technique where you can identify the emotional tone of a particular text or sentence in terms of negative, positive, and in neutral cases also. So now next term is explainable AI. While I was researching about my topic, that for what topic I should go, one of my mentor has been told me that you can go for explainable AI, which was a very new term for me. Then I also go through that what is explainable AI in actual. So And what explainable AI is, if you are how AI predicted this particular result, it can be understood to how human. For example, why AI has predicted the particular review or particular prediction, it can be understood to us and to make the trust and transparency in between the understanding process. And the machine learning algorithms I have been used are, some of them are supervised learning machine learning algorithms and some of them are deep learning algorithms. Next slide please. So I have been going through, there are some research gaps. For example, many of data sets have been used for the only sentiment analysis, but I have been choose two different data sets for my research work, where one of them was for Yelp review data set for sentiment analysis and one of them was for fake or real review authenticity prediction. And unique contribution in this paper can be explainable here, where I have been used line, especially local interpretable model agnostic explanation, which locally predicts that why the review is predicted as such, and it identifies that particular words, that how that word has impacted for the particular review. Next slide, please. Next one, please. So this is my methodology in data set selections. I have, as I previously said, I have taken two data sets. One is of Yelp review data set and the another one is fake review data set. Where Yelp review data set is used for sentiment analysis, which is labeled as 0 for the negative and 1 is equals to positive. And authenticity, the fake review data set was measured as CZ, computer generated reviews, and OG, original reviews, where computer generated are named as fake 0 and original reviews are named as 1 for viewer. Now data processing, as we all know, if you want to train our model to process the data as earlier, for example, tokenization, normalization and cleaning the data sets, for example, removing space words and removing any other exclamatory marks etc. Next slide. As machine learning algorithms only take numerical data sets. So label encoding says that converting the categorical data into numerical format for model interpretability. And I have been used these 6 models: LSTM, LSTM, CNN, LSTM, STM, random forest, and neighbors, where I have been performed these tasks in my model prediction. The sentiment polarity prediction has been used for all the models. In review authenticity, I have determined that the particular review text is fake or real. And I have also determined a product category classification, where I use my fake review data set and then trained it further to predict the category of a particular data set. Next slide. This is our review prediction, where I have been given the particular review to my data set. To my model, it has been predicted as such sentiment predictions by particular algorithms. You can see as their name-based, random forest, SVM, STM, and so on. And so similarly for the fake review predictions, this has been also rated as a bar chart graph. Now these were the product categories for sets, and that why particular reviews of product category has been identified as such, as you can see in this. Next slide, please. As model evaluation metrics, as we all know, checking the performance of a particular model, we need to go through some accuracy matrices, for example, accuracy, precision, recall, and Apple score, to predict that which model has been performed as well as in terms of model prediction and I have been used these results, these algorithms. Supervised learning के case में I have used name-based, random forest, and SVM, whereas SVM is results as such as 8.9, as you can also show in the graph, and the best model which are performed with sentiment For sentiment analysis, SVM is performed as well, and for the fake review prediction, where labeled as fake or real review data set, value LSTM is performed as well, and for the product category prediction, name base has been performed the customer, and you can also check out here the some accuracies of particular models. Thank you. These are the results. These are the table where all the accuracy of particular models has been identified. Next slide. So line is a highlight important words influencing predictions, improve interpretability and trust in model outputs. Next slide, please. Yeah. So here it was my review text, and this was the line which was applied for this particular review, where these words are highlighted words which are impactful for the review prediction. For example, why this particular review is predicted as negative or neutral. These are the words which are highlighted with the blue color are denoting that for negative in negative context, and for the orange वो neutral के लिए representing करता है. Same for the real and fake predictions. These orange words are जो highlighted है orange से, they are presenting fake words, and they are and similarly for the real words. Next slide. This was the particular review where these was the keywords which are particularly identifying that which word was most impactful for identifying the review as fake or real. For example, the product was amazing. I absolutely loved it. So these were the product. Product has has been the most dominating word which has been predicted that the review is real or fake, which is responsible. Next slide, please. So I'm concluding it with this that I have been decided that for review prediction, review prediction in case of sentiment analysis, SVM has been performed the best, and for fake review prediction, by LSTM has performed well, and for the product category prediction, Nailbase has performed as well. Next slide, please. So, as future work, a real-time application can be developed. Some large data sets can be used because deep learning algorithms are always used for the large data sets to understand the neural network in between the connection of the textual data and BERT and robot Icdsea deep learning models can be also further identified as such. Next one. These are some references where this one was the paper which was motivated me to identify applying explainable AI in my particular research work. Thank you. Thank you, Ms. Namrata Jain.
Today we have Dr. Gaurav Saxena with us. He will be speaking on a fascinating and interdisciplinary topic, application of data science and machine learning in nuclear physics and astrophysics, introduction to quantum computing. This session promises to bridge emerging technologies with fundamental physics in an exciting and accessible way. Please join me in warmly welcoming Dr. Gaurav Saxena.
So, myself, Gaurav Saxena. I am from Government Women's Engineering College, Ajmer, and I am assistant professor in Department of Physics. So, do not shoot here on the conference of data science and all the engineers sitting here. So I have been told that you are the future of this institute and Rajasthan. So I hope the future will look here that what I am going to share, what I have done in all my last 15-20 years journey of my research and what is new for you. So I'm sure that the coming 20-25 minutes I will share some of my experience and that definitely benefit all of you, the engineers who are sitting here. So first of all, I am very much thankful to the organizers of GID. So giving me the chance to share my thoughts on data science, machine learning, and my talk is related to some of the application. And you all people who are dealing in computers, they are actually can do this kind of work with all of your skills. And then the second part of my talk, I wish that everybody sitting here can have the attention for the introduction to quantum computing. I don't know how many of you have heard this name. I don't know how many of you have been facing this kind of new things related to quantum computing. But definitely I will give some checks on introduction to quantum computing. And very much thankful to the first talk of this session, so inspiring talk, Mathur sir. So with this talk, and you have set the atmosphere, so I am now starting what my journey has been. So next slide. So I am basically nuclear physicist. I am doing some of the research in nuclear physics and astrophysics. So I am thankful to my collaborators there who are and with whom I am doing continuous things, and I have switched myself from the core physics to the department of computer or some of the simulations kind of thing. These are my groups and my research students. Please go ahead for the next slide. Next slide. So I just want to show you how the data science been important for astrophysics or nuclear physics. If you can see that there is solar dynamic observatory, and that collects 1.5 terabyte data daily. Not only this one experiment, there are a list is there, a very few. For example, if you get baryon oscillation spectroscopic survey BOSS, that is again containing a lot of data daily. In fact, the HERA project generates 50 terabyte data daily. These are the experiments going on a daily, night or day basis. If you go for further, this SDCC takes the data for 200 billion galaxies and stars. So we have a huge data which is related to astrophysics. If you go for nuclear physics, next slide please. So if you go for nuclear physics community, next slide. Yeah, thank you. So this is what the experiment which probably you have heard in the newspapers in the recent time, LIGO, Virgo, Kagra. So these all experiments detected 90 events so far, which are neutron star merger, binary black holes. You can see the image of the black holes there, and then binary stars merger, the right side of the image, which have been given the Nobel Prize in the recent past. So these all observations are not the observation which are actually having the click and then you observe it. Behind these all observations, there is huge data sets. You probably know the last one, this NASA have given so many of projects. Can you just go upwards? Hello, can you just go upwards? The slide band. Okay, so this is what the James Webb Space Telescope and many of the different projects of NASA. What they are doing, they are taking data continuously, and that is what happening. So the data is playing a very important part in our day-to-day life. Okay, maybe you might not be very much familiar with all these projects, all the black holes. Of course, we are not familiar with the black holes. Otherwise, we are not been here. But okay, but if you are not familiar, then I think everybody sitting here is familiar with this one. Next, please. Next, please. This periodic chart. I hope everybody has seen it in this secondary or senior secondary classes. So this periodic chart is actually containing one element, any cell, any one cell contains one element, but for one element there are lot of isotopes. Not only the isotope, for each isotope there are so many data. I'm not going to detail in the physics, but there is so many data related to one cell already there, which you know. Can you go ahead? The next slide. If you come to the nuclear landscape, this is what my strength or my work for the nuclear physics. So if you have this data, look the yellow shade. This yellow shade contains 3000 nuclei that are known, okay, to us, on which we rely our day-to-day life. The green portion of this nuclear chart is still the portion which is undetected, which is not being detected by any experiment, and there are far possibilities so that they can be predicted in the near future. And now the role of data science play an important role. That this yellow lines has, we have the data here, and we can predict the data of this green particular region. And there the data science and the machine learning plays a very important role. I am telling you not machine learning, I am telling the application of the machine learning. In fact, with this small data set, the machine learning can predict this any of the feature of this nuclear chart very precisely. And that is what the computer science engineer, that is what the you all engineer people are actually very handy for all of us kind of physicists. Can you go ahead? Next. So basically, what is the correlation? Already Usha madam has told us about data science and etc. So the artificial intelligence is actually a set, machine learning is subset, and look here, the most of the portion of the machine learning is comes in the category of data science. So any of the person who are studying this machine learning, they are data scientists. Any of the data scientists actually must acquire the knowledge of machine learning. So what I have done, I will just show a glimpse of that. Go ahead, please. Next. So what we do, we have some nuclear experiments, we have the data, then data is unprocessed data, then to get the unprocessed data, we can rely on the machine learning method. After unprocessed data, you can rely to get the real data by the machine learning method. These, just go ahead, upwards, little, yes. So this data can actually imply in the nuclear theory. You can refine nuclear theory, then you can go for the nuclear experiment, you can refine nuclear experiment, and this cycle will go on until you reach to a physics of interest. And that is where you all engineers are actually required for any kind of research field based in the physics, in astrophysics, in chemistry, or anywhere. That is, with this machine learning kind of technology, you can actually advance us, you can provide us the knowledge which might be we do not have since last 100 years of theory. And that is where this machine learning plays an important role. Next slide, please. So what I have done, I have just glimpsed you the one important contribution which is from based on machine learning. Yes. So this is what I have done, that we have modified some formula, that's a separate issue. But we apply the machine learning method to find the alpha decay half-life. Now I hope everybody has done some of the half-life kind of thing. If you do not know, then you have studied this alpha, beta, gamma, etc. in your secondary classes. So we have predicted half-life of alpha decay. It's not directly from any of the radioisotope. We predict it by the use of machine learning method. You go further, next. So these are the matter, I think this the student already have described, and you all people are very much familiar with this kind of algorithm. You can go ahead, multi-layer perceptron, this ANN and decision tree. Next, please. Because I have very less time given. So next, please. So this MLP, XGBoost algorithm, very gradient boosting technology. So next, please, next. So we have done some RMSE testing, and this RMSE testing you can see. Next. Yes. So this RMSE testing, all these machine learning methods are found to be very accurate. And I am saying it because all the principles which rely since the physics, since the theory of that particular alpha decay, your machine learning methods have been applied and they found it very, very good. So that's what the test which we have done, and we are able to publish this next speech. In fact, we have calculated some of the half-lives already. If you can see the last two columns are not theory. Last two columns of the half-lives are actually from machine learning method. And these machine learning methods are actually trained by the data set what we already have and you have seen in the chart. And that is what the direct implication of the methods of you people that are working in this field can actually give us a beautiful, beautiful thought and a beautiful prediction. Move further, next. I can skip the next, yes you can go ahead. I can skip these two slides, you can skip it. Next. Another word I wanted to share, but okay, due to lack of time, we can may go ahead, yes. So what is the next please? So, yes. So what is that? What I'm saying is that we have a lot of data, not me, you all people are having lot of data. What is next future? Where we are going? So if you have the GPUs of NVIDIA, you can use it. Then you can use the parallel computing, you can use, you all computer guy there, right? Then what next? Where you will go with this sort of data, this huge amount of data? And we require a lot of processing now. So if the parallel computing will take care of everything in the next 10 years. So the next 10 years, the future might be for quantum computing. So I have been told by madam that you touch some of the things that will inspire the students to work for you. So all the students who are doing the BTech or the MTech here in computer science or not in computer science, I must say that please go for quantum computing. This is the next 10 years, it might be the future of this world. In fact, before starting, I must tell you that Government of India already has given 6,000 crore rupees grant for the national mission on quantum computing. The Government of India is establishing now the network for quantum computing, and I wish that everybody sitting here at least do some project, at least do some internship, or they can plan their career in the field of quantum computing. So that's what the quantum computing. I will give 10 minutes of this introduction. It's very simple introduction, but just for your sake. Next slide, please. So we have this generation of computer already, you know, this is the first generation, then second generation. I hope you remember vacuum tubes, and of course, you have not seen that, but yes, the initial size of the computer was bigger than the room, right? So we have this, the first and the second generation. Next. So if you go further, then there was the generation of the computer that is third and the fourth generation when we had the CPUs, etc. Then microprocessor came, right? Everybody knows now, 8085 is the basic now. Go ahead. So you have the generation of computer that is the fifth generation that we are using right now. So we are working on this one. And if you go further, the next slide, if you go further for the next slide, this is a Moore's law. And that is what the future of computer. What is happening? Happening is that if you see this timeline there, and if you see this chart, this is not law actually, this is what is happening in industry. So as you were processing there towards 2025, the size of transistors is now being a molecular size. You have reduced the size of transistors. Okay, with the computer with a big room size now in your pocket, you have a good processor in your pocket. So the size of transistor has been reduced tremendously. If you follow this line, so in the age of 2040, when you will be standing here and you will remain in the top for the next generation, then at this particular age, the size of the transistor would be the atom size. So small. And if you reach to the atom size, then Richard Feynman already said atoms on a small scale behave like nothing on a large scale, for they satisfy the laws of quantum mechanics. So if you reach to that stage, we will definitely. So the quantum mechanics will turn out to be very important. So what will happen? Let's see. Next slide, please. So what is quantum mechanics? I know that everybody here is not quantum mechanics student, and they don't like it also. In fact, I'm not saying nobody understands quantum mechanics. This is already been quoted by Richard Feynman. He said it. No, you are not going to be able to understand it. You see, my physics students don't understand it either. Why? Because that is because I don't understand this and nobody does. So nobody understands quantum mechanics, but for you to understand quantum computing, quantum mechanics is not necessary. So even if you are a simple computer engineer, you can go ahead with all the algorithms, all the things, whatever you have been doing here, and you can form yourself in the quantum computer. Go ahead, please, next. So how the quantum computer is actually. So the quantum computer is a computer which actually follow the laws of quantum mechanics for sure. And look, these three words. These three words are maybe the future of you, right? So massively parallel computing through superposition, through entanglement, and through decoherence. So very soon that could be the part of the curriculum from Icdsea institutions, that we have to go for one of the paper, the essential paper of quantum computing, and very soon you will get to superposition, entanglement, and the decoherence. This is very different than the classical computer what you have now. Next slide, please. So where the evolution of quantum theory or quantum technology begins? I must tell you, this is the year of quantum technology. So we are celebrating the year of quantum technology this 2025. And this is not new. We are already late. If you are here first time this name quantum computer, you are already late. I am late because I have started quantum computing only in the last 1 year. But definitely we are late because in 2000 already first step IM quantum computer by May. Already made. In fact, D-Wave quantum computer was analyzed in 2007. IBM had given already the roadmap of quantum computers. And we can see how the quantum computers are there. Please go ahead. So, go ahead. Next slide. So what does a quantum computer look like? It's very different than you have in your laptops or in the desktop. This is what the quantum computer, the Chinese 76 qubit, I am coming, qubit. And then this is one of the computer, this is a computer of 53 qubit. And that is what the first computer from IBM, quantum computer. This looks like that. Next page. And very soon, in 2025, IBM is launching the most important, or in fact, most largest quantum computer. Please go ahead. IBM will release and the largest quantum computer in this year, 2025. So I hope that you will see it very soon. Go ahead, please, next. So, in quantum computer, just giving the 5 minutes to the glimpse of that, we are not relying on bits. So you are engineers, you are using 0 and 1 in your all the things, whatever you are using. So now this is called as C bit, it's classical bit. For quantum, we will use Q bit. Okay, the difference in the C bit and Q bit is that in C bit you are having 0 and 1, that's fine. In quantum also you will have the 0 and 1. 0 and 1 is not a number in quantum. It's the state, number one. Number two is that in 0 and 1, if you are processing, so there might be, if suppose you have 2 C bit, so you will have the number which will propagate through your system is the 0, 0, 0, 1, 1, 0 and 1, 1. Am I right? Am I right? And you can process the data by using any one thing. Either it will be go for 0, 0 or it will be go for 0, 1 or 1, 0 or 1, 1 at a time. Agreed? Agreed? No, I will not the other. I will not see. Okay. So everybody know it, right? So at a one time, you will actually allow to process 0, 0, 1, 0 or 1, 1, anything, right? But for qubits, what the important part is that qubit you have the 0 and 1. More than that, with the 0 and 1, you can have the superposition of 0 and 1. The superposition means any number which will lie between 0 and 1, superposition can go for, you can transmit it. So it extends the possibility of parallel computing in its own. You do not require parallel processor for doing that. You do not require for the 0 and 1, both are okay, but you can make any combination between 0 and 1, and that is what the beauty of quantum computing. Please go ahead. Please. Okay, so the difference between C bit and quantum bit is that you can have your classical bit which might be 0 or 1. But for quantum, it can be 0, it can be 1, or it can be the mixture of 0 and 1 at a time. And that makes this beauty, okay? This can be measured, this cannot be measured partially. Okay, and there are under any other some things which you can get it from there. But the beauty is that for qubits, you can actually process parallelly. Go ahead for the next. So advantage of qubit, you can see, if I want to double my power, the power of a classical computer, so I require 32 bits to enlarge up to 64 bit, and that will double my power. For quantum computer, if you want to double the power, the 32 qubits, and you just add one qubit, it will double the power. Not only that, if suppose I operate with the parallel processor and I operate with 2 power n number for classical computer, so with n bits require 2 power n steps, and that is what you people do. So if you come here, a 64-bit computer can perform 64-bit binary number operation, right, at a time. But for quantum computer of 64 qubit can perform 2 to the power 64 operations at a time. It is 10 raised to power 18 times powerful than the classical computers what you have. Now those persons who are interested in parallel computing, I am saying it that the future is coming, and that is once we rely on a qubit, non-qubit. Please go ahead. It's very familiar, the gates already from class 10th standard we have right side, NOT gate, AND gate, etc. These are very trivial things nowadays. But for quantum computer, these gates are not valid. We have to rely on some other gates, and these gates are X gate, Y gate, Z gate, and very important hard gate, and so on. So of course I am not going to detail of these gates, but yes, in the future these all right side will be vanished, and definitely we have to come to these new gates. Next, just giving the glimpse that how the quantum circuit will look like in future. It's not your gate kind of thing or not microprocessor. The quantum circuit will look like this kind of. These are the gates, hardware gate and X gate, Q0, Q1, Q2. These are the qubits as the input, and we can have such kind of circuit in your quantum computer. Next, please. Just giving the hint. In terms of programming, your Python will work, I don't know. Your C++ will work, I don't know. But there are some specific programming language already being developed. In fact, on the one thing on which we are working is the IBM Qiskit tool. Qiskit means Quantum Information Science Kit, and IBM has already launched it. We are working on it, and it's free for all of you. For 2 minutes, they provide, for 2 minutes with the one login, they provide their quantum computer to run your code, which is already being developed in the quantum circuit. So you can try it with the Qiskit. Next. Thank you, and this is what from my side. Thank you. So I hope that this talk might be the introductory, but in future you will definitely get the feelings of the quantum computing in your career. Thank you, thanks a lot everyone.
Thank you for sharing your expertise and inspiring us all with your words. Now, I would like to call Dr. Ruchi Dave to share insights on her research.
Good afternoon, everyone. Thank you, GIT. Thank you, organizers, for inviting me for this wonderful conference. I know this is going to be lunchtime, and I am definitely going to give you food for thought. And definitely I'm not bore you with my PPTs. No PPTs. But I definitely would like that, some of you should interact with me. Since I'm going to, I've very well taken the advice from Ms. Vadera. I've actually inspired with Dr. Saxena. I've inspired in the sense that, to stand here and to speak about something, such type of work those all the professors have shown you. So you have to build that. You have to work upon that. And sir, for you, I just want to say that I don't know how many of you are actually listening to all what the speakers are saying. So this uncertainty will definitely leads to the certainty that one day they definitely will be learning the future technologies. And when I talk about future, so future is here in front of me, all of you, those who are sitting here. And probably you actually are trying to understand that what it is all about, what data science is all about, what AI is all about, and probably 100%, I think each one of you have have taken the first step and tried artificial intelligence. Yes or no? Give me a loud yes, come on. So all of you have done ChatGPT, some of you might be having Gemini, some of you might be using, and assignment दे दो यार 2 मिनट में बना देंगे ChatGPT है ना फटाफट. Okay, so definitely, because I really like lazy lads, because they are the promising one, because वो इतनी जल्दी काम करते हैं जितना तो कोई भी नहीं करता, right? So I really want the backbenchers or the lazy lad who actually would like to finish it within the time, given the time 5 minutes. यही तो टेक्नोलॉजी होनी चाहिए कि हम सोचें और वो बना दें. भगवान तो ऐसे ही होते हैं, God is like that. You wish. आपने सुना था ना उस जिनी के बारे में कि आप विश करिए मेरे आका एंड मैं आपके लिए कुछ क्रिएट कर देता हूँ. हाँ भाई, सुना था या नहीं? तो आपको ऐसा नहीं लगता ChatGPT में मैंने जो लिखा वो सामने आ जाता है? तो ये जिनी नहीं है छोटा सा. You just have to rub it and you just have to, with your fingers you have to just illustrate and it comes in front of you. But how it comes? Have you ever thought of that? What is the technology behind that? Now ma'am Bhadera said that it is quite vast. So I cannot be talking about everything here, right? Because again the time is also the constraint. So let us talk about students' favorite future of this generation, and which is artificial intelligence. So what is something new I'm going to talk about? So let's talk about generative AI. Come on, I know, everybody know, madam, हम सब ChatGPT use करते हैं. What is that you are going to teach us? क्या बताने आए हो? Oh, my dear, if there is anybody who can tell me that how this data science and the generative AI, which I'm going to talk about, how they are connected, where it fits in and what is happening behind the scene. So my aim is to sensitize all of you, to make aware all of you about one topic, and that is generative adversarial networks. My dear students, this is the model, this is the framework which is behind the scene, behind whatever you are doing. You are writing something and that's happening in front of you because of generative adversarial networks. Now this, as one more thing, when I say this, one more thing I want to admit, and I admit with full integrity that no model can be trained without a good, clean, clear data. And data are often, they are not clean, they are not clear, they have a lot of noise, and whatever noise you have, you really have to process and you have to make the data worthy of processing of, So, but again, if I talk about this, then we need to understand. It is just like the professor is teaching and one studious guy is noting down everything. And my students, all of you, today's student, you all of are taking QR codes and taking my lecture notes home. I'm doing it like that, okay, because now it is the time of screens. So you're not even writing it down. So when you're not writing down, it has not been registered yet. Got it? You'll accept it or not? Definitely the QR is there and it's in my phone, I'll see it later, but it's not there, So now the purpose of teaching learning is that there is one person, whom you call a professor, a teacher, faculty member or guru, and the other side the disciple. the role of two of them that makes a class is that one is giving the training and the other one is being receiving the training or trained. Now, without data, can you be trained? Can you be trained? So any model, just assume yourself as a model. No model can be trained without the right kind of a data. And you have to understand that from where the data is coming. मेरी बात समझ आ रही है? So whatever there is in life is in computers. Computers अलग नहीं है आपकी जिंदगी से. They are the part of your life. मैं आपको एक छोटी सी अपनी बात बताती हूँ, उसके बाद इस टॉपिक को शुरू करती हूँ. Then you know, when we teach engineers, when we create stars, when we make engineers, then first of all, there has to be one engineer inside me also, then only I can make you an engineer, another engineer, okay? Now, so again, I had a thought process that, I also need to do something, and yes, very proudly say that I'm having one patent registered under my name, and the entire thought process, entire work, everything being done by me. And my sister, she is the mathematician. Both of us discussed and we did it. And we were quite appreciated by the CM Vasundhara Rajiji. And this is about, the amulet that we have designed for women's safety. We did that. And now this, when I say this, so why am I saying? Because, there was a thought process that I have to do. And then I started working on that. And then we designed something. And something beautiful comes out of it. And then we got a picture. So now you also have beautiful mind and you definitely can create a lot. Coming back to the topic about which I was talking about, artificial intelligence. So the thing which I'm talking about, generative and adversarial networks. So how it happens that you dream of something, you say that I want this kind of an image, and the image appears. Sometimes, some erroneous image also appears if you're using the tools you all are using. So, how it happens. You all know that just now Richmond discussed that machine learning it's a machine learning model, and it learns from you. So how it is learning from you. And who is training that model? You might be saying, there is one website I like to tell you, peopleslab.ai, right? Now this is earlier colleges used to train students for interviews. And there used to be so many mock interviews, and nowadays also the TPOs are rigorously working for that. But what is happening? AI is giving you the platform where you yourself can conduct mock interviews, and you'll be suggested all the flaws and everything, whatsoever. So I just want to tell you that AI is the future, and this generative adversarial network, this model is actually nothing but the two neural networks who are working against each other, like the student and the teacher. They are working together. So one is, creating, one is creating, and when I say creating, it does not mean that, it is learning. It is learning on the principles, but it is creating from the scratch, which means that artist, it is an artist, and who is correcting? So one is the generator, and the other one is the, is the discriminator, that whether this is right or wrong. Just like you submit the assignment to the faculty and say, no, you have to correct it, this part, do it again. Or the project, no, the documentation has a problem, go back and do it again, right? Similar manner, this model has one generator which is generating. Now how it is generating? It is learning from you. When you are asking something, you write something in ChatGPT, so it is learning from you, and then again it is refining, and it is giving you better and better result, and it is giving you, if I talk about images, it is giving you some real images as well. So which means that the data which you have has to be clear. Means the concept that you have in your mind should be clear. So now our generator, we can assume that it's just like the TV screen. It is random, only random we can say. And then whatever you say, it has been converted into the image, and the discriminator, then it converts it to the image that compares with the real image, and finally you get an image in front of you. Now, if I further talk about that, what is the real life application. What is the real life application? Now, there are so many. In the field of media, in the field of art, you can design wonderful art. And you know, it can design it from the scratch and you can, you know, it is my own design, my own thinking, and that is what you are doing. So behind the scene, generative adversarial network model is responsible for what you see today. And why, you know, I'm talking about this because all of you have seen the deep fake. Just one student was like mentioning. So one deep fake is again the controversial deep fake is here. That is because of generative adversarial network. And again, it is because, you know, you just can fake the videos and, you know, even you can put the words and then you can find, and there are so many videos, they are flooding on, you know, Facebook as well, where you find that, you know, some celebrity saying something else or whatever, you know, so and audio both being faked. This is being done by now. This is the negative or the dark part of GAN. Another which can be very well implemented, they are the gaming portals. Now there it can be used. Now it is unique. Why GAN is unique here? I really appreciate if you can go and research and can again contribute to this research more. That why it is unique. It is unique because it is not recognizing the patterns. It is not recognizing any kind of pattern. It is creating it. So it is creating it from the scratch, and that is what it is. It makes it, you know, very powerful, I can say. So, you know, you have learned something which is some definition which is given in the class, and you are mimic whatever is being taught in the class. No, my dear. You know, GAN is not like this. It will be writing from the scratch. It will give you a new perspective. It will give you new image, new art form, and from that you all can get benefited. So all these students, those who think that I am an average student and what is there for me in art, what is there for me in music and media, there is a lot to do, and I wish that all of you should understand and learn more about generative adversarial network, and definitely you can take a, you know, you can take a plunge, you can actually go and learn more about this. I hope you've understood something from this talk, and definitely would like to do more research on this. Thank you so much. Any questions?
Thank you, ma'am, for sharing such valuable insights. Now I would like to call paper ID 313. 313.
Hello. Good afternoon, everyone. So we are here from JCRC Foundation, Sitapura, Jaipur, and the topic of our research paper is predicting resting heart rate anomalies using heart rate data and explaining the predictions using explainable AI techniques. So good afternoon. I am Asmita Goyal.
I am Radhika Rajavar.
So let's begin. Next slide, please.
So we are very well aware about what the different aspects the AI is in right now. So when we talk about the digital watch, the smart watches, what are the main key aspects of those? Heart rate, blood pressure, and our movement, our calorie intakes and everything, right? So in 2025, if we look at the data, we realize that there has been $400 million extra in smart watches, which is a 475% increase since 2020. So basically, we realize that AI is being integrated into healthcare way more than we were expecting in the last 5 years. So here we can see that random forests and XAI tools are being integrated in healthcare and we are using it.
Okay, so we can see that there has been a very much increase in the use of smartwatches and we are all very much hyper aware about it. But what is the smartwatch telling us? For instance, if it tells us that your resting heart rate is abnormal, can you trust it? Do you trust it? Because we trust technology a lot these days, I know that. But how do you know that it is accurate? Okay, so you go to a doctor and then, for example, the doctor also uses ChatGPT, which does not explain its answers at all.
So basically, when we are talking about medical field, our most important thing is the reliability in the doctor. We make so many word of mouth of the doctor. We actually do research about it. Then go and pick one doctor after so many analysis. So how can we trust a ChatGPT or DeepSeek kind of technologies when we do not even trust doctors without a good word of mouth?
Right? So, why do we trust AI so much? Do we know how it is thinking? No. Do we know what features it is accepting? No. We just know that it is a complex web of neural networks which we cannot unravel once it has been made. Right? So, for dealing with this, we came up with XAI, which is explainable AI techniques. And these models like ChatGPT and Gemini, which do not explain, are called black box models. Okay, so we can move forward.
So in ChatGPT, when ChatGPT came first, there was two major issues that ChatGPT was facing, one of which is this one. 9.9 and 9.11, which one is the larger? So when this question is asked to ChatGPT, it always said that 9.11 is greater than 9.9, which is not true. So this is such a small mistake that we can see when we are asking a simple question. But when we are giving a huge data set, we are unable to ever analyze that such a small mistake has been made. So when we asked the ChatGPT what mistake that it was making, it was that it was analyzing 9 with 11, not 0.11 or 0.9. It was actually equating 9 with 11, and 11 is obviously bigger. So it just was giving the wrong answer. At the same time, there was another mistake that it was making, which was the strawberry mistake. So in strawberry mistake, when you ask the ChatGPT how many R's are in there, it will always answer 2 only, which is again wrong. And when we ask the ChatGPT what's the issue, why it's being wrong, it cannot analyze it, it cannot explain why exactly this mistake is coming and became a huge meme on internet. So to eliminate these issues, ChatGPT came with explainable AI. They started explaining their process, their thought process, how the process is going, and everything. These kind of mistakes should not happen a lot because we are not able to conclude the data well because of it.
Okay, so this is a very, very small example, right? But the data we are talking about is heart rate data. So can we afford mistakes there? Even a 0.001% mistake. I know you all agree with me that we cannot have any mistakes in that field, right? So we have to understand, and if we cannot understand, at least medical professionals should always be able to understand if they are integrating technology into their daily work, that how the features are being selected. Is it wrong? Is it right? Do they agree with the thought process or they do not agree with it? Right? So let's move forward. Okay, so I have used this term like 2-3 times, explainable AI. So what is it? So as I said before, explainable AI are AI models that communicate their logic and process very clearly, right? Even the father of AI has said that we cannot understand its thought process, but right now we are dealing with that we can explain the thought process to human beings, and if human beings agree, great. If they do not, then we can make changes to it.
This gives us reliability, trust, and confidence in our process. And it also eliminates the black box model.
Okay, next slide please. Okay, so smart technology in healthcare. Accuracy alone is insufficient. We have so many criteria right now. We can define accuracy of any model we are using. We can check, accuracy we can define, or we can say that how it is classifying. We can view the outputs. But again, we are dealing in data in very, very huge numbers, very large numbers. So how are we able to trust it? So smart technology in healthcare is increased drastically. A wrong but confident prediction without explanation can lead to a misdiagnosis. Obviously, if humans can do errors, then machines can obviously do more errors if we do not optimize it properly. Okay, so what we need is user trust in automated systems, and yet again that trust needs to be verified. Trust but verify, because this healthcare is not just a game, it's not just an experiment, we are dealing with the lives of people. Moving on, next slide please. Okay, so the data set we had was a Campbell data set of a study which was in Harvard in 2020. So what the data set included were various features. In those features, there were sleeping heart rates, running heart rates, resting heart rates, and calorie and everything. So that data set is not, this is a limitation of our study, that data set is not particularly for this purpose, for using Icdsea techniques, but we have used this data set so that we can understand that how Icdsea can tell us when wrong features are being accepted, when wrong features are being given more importance. So this is a partial dependence plot of various features. In this study, we made a random forest model to classify any resting heart rate into normal or anomaly. Okay, so here we can see that when we plot a partial dependence plot of various features, for example steps, okay, so we can see that it is declining. So the declining rate of these graphs tell us that these features have not contributed very much with increasing data set. Next slide please. Okay, so global importance features. We can see that the heart rate is the feature which has contributed the most in our study, and that is correct, right? We need the resting heart rate to be the most important feature. We do not want any steps to be the most important feature, right? So we can see here clearly that the most important features are at the top and they have contributed the most in our study. Next comes the line plot. In the line plot, this is the line plot. What it does is we deal in huge data sets. But what if we want the outcome of a particular person? So for that we use the line plot. So this particular line plot is for a person who has been whose resting heart rate is classified as normal. Okay, so we can see that on the left hand side, all of the features which said that it is normal, and on the right hand side, all of the features which are orange that said this is an anomaly. So at the end, we can see which features said that it is normal, and now any doctor or any qualified medicine officer can tell us that no, this feature is wrong. You should not have used this. You should have used this, and we can tweak the formula and tweak the model according to that. Next slide, please. Okay, coming to the limitations, as I told you earlier, this data set was not exactly for our purpose, but then it is also an advantage for us because we can understand that which features are not there for us and how Icdsea tells us that which features are important and which are not important. Lack of clinical validation. Labels were derived without medical oversight, limiting real-world diagnostic reliability. Of course, I'm an engineering student. I left biology after 10th. I'm sorry, I do not have very much knowledge of it. So that was a significant limitation. Interpretability versus usability. Icdsea tools require domain knowledge, challenging for lay users or non-technical healthcare staff. Again, biology students may not know maths, they may not know machine learning. So how do we make that into a model such as ChatGPT, where they can explain their problem and we can explain the answer to them? But it needs to not be a black box model. Generalization issues. The dataset lacks diversity across demographics and health conditions affecting model robustness, and the high computational cost of the models. Well, the high computational cost is for all AIs, whether they be black box models or they are XAI models. That is the cross we bear if we want to deal with AI. Next slide, please. Future scope. Okay, so whatever limitations we said before, of course we can remove them and that will be our future scope. So our limitations are what? The data set was not according to our problem. So we can collect a more focused data set for our problem. And we can have real-time explainability by consulting medical professionals or medical students, and we can integrate actual models which can be of better use, and the model can be refined further. Human in the loop systems. We can incorporate clinical feedback because each and every data set, each and every patient's information is important to understand the trends in the data. Multi-model integration and user-centric XAI. So we have to create intuitive explanations using visuals. Just now I used bar plots and line plots and partial dependence plots. If we cannot visualize, then we cannot understand using a large grid of Excel sheet. That will be very complicated for anyone to understand as a human being or even as a machine. Visualization is our key where we can understand everything more clearly, right? Okay, so next slide please. So the conclusion is that black box models are the trend right now, but we need not to trust them so much because they take our data and they do not explain to us that why did they take the data and how are they using it, right? We have no control over that, so we should turn to XAI and we should focus on explainable AI techniques, and major companies should do that so that we can have more clear and good smartwatches and healthcare and in other domains also. So thank you so much. I hope that this was my first research paper, so I hope I did something good. Thank you so much.
Thank you authors for your efforts. Now I would like to call paper ID 313 for their presentation. Sorry, I would paper ID 132. I repeat, paper ID 132.
Good afternoon, everyone. I am Navneet Prakash, and we are presenting our paper on the topic of AI-powered healthcare keyword detection. We are a team of three: Lavi Jain, Pratik Anand from my year. Next slide, please. So, whenever we go to a clinic to meet a doctor, there is a problem. There is that we get prescription in a written format, right? So whenever we get a prescription in a written format, what we do is we don't understand that because of the writing of the doctors, of course. And the second thing is we don't get that prescription in an automated format like the symptoms and the diagnosis we are suffering that will be in a column or something like that. So that's the problem. And for doctors, the problem is that they manually write those prescriptions. So we are working on an algorithm which is a three-layered approach we are doing. The first layer is NLP, second layer is Google Gemini where we are using speech-to-text detection, and the third layer is TensorFlow.js, which is a framework, and we are developing these three layers. We are using these three layers, and then we are generating a prescription which is an AI generated prescription. Just a communication is happening between a doctor and a patient, and those communication will be recorded in a browser extension, and those speech will be converted into transcriptions in the prescription thing and will be automated, send it to all the patients and their workflows. Next slide, please. So that's our research workflow. The first we are doing is we are collecting data. So from where we should collect those data, right? So we are collecting those data from hospitals, those patients who are in the like ICUs. So those data are collected from the hospitals, then and other sources also. Then we are pre-processing those data in the four form. The first form is tokenizing those data, second is normalizing those data, third is lexemizing those data, and fourth is stop mode removal. So what we are doing, we are taking those speeches and we are pre-processing those data for finding relevant keyword. Like if I go to a doctor and I said I am suffering from a heart disease, I am suffering from any liver osmosis diseases. So whenever we go to a doctor, we talk in a very friendly manner that डॉक्टर साहब देखो ये हो गया मेरे को, मेरा हेल्थ खराब है, मैं छींक भी आ रही है, पेट दर्द भी हो रहा है. बट इन सब में रेलेवेंट कीवर्ड्स कौन से हैं? रेलेवेंट कीवर्ड्स को हम एक्सट्रैक्ट करते हैं, फिर एनएलपी से उसे प्री प्रोसेस करते हैं, देन टेंसरफ्लो जीएस से उसे मैच करते हैं, उस मॉडल से मैच करते हैं कि वो डायग्नोसिस सच में एग्जिस्ट कर रहा है या नहीं. लाइक if someone is suffering from a heart disease, then those heart disease keyword will be matched with TensorFlow.js and then it will go to the model for training. So that's the pre-processing of data. Third is model training using TensorFlow. So many of you are data scientists and our beloved students and our respected faculty members are doing great work in data science. So there is a commonly asked question: is Python is necessary for data scientists? Yeah, it is necessary. But if you are a web developer and you are working in JavaScript, you can use open source frameworks like TensorFlow.js for your project and for your research. And you can add layers like an algorithmic layers using beneath of those TensorFlow.js, and you can literally train a model using JavaScript framework. So that's the advantage of being a developer for a web developer data in the domain of JavaScript. That's why I think many of you are here that Google is also shifting from Python to JavaScript for model training. So that's we are doing. The third is we are deploying those real-time deployment. We are deploying those models for open source, like anyone can use those models using an APIs in their personal projects also. So we are doing that. So these are flow of our research flow. Next slide please. Next slide please. So these are our data sources where we are collecting data. The first is mimic third, which is the data from ICU's patient. The third is EHR, electronic health records. So there are many platforms, they use electronic health records. So we are extracting those data to train our models. Third is NH clinical data sets, and fourth is UML categories. So what are these things are doing? If any keywords are extracted, it will be in that it will be going to the dictionary of a collection like data in the symptoms like for health records, symptoms for heart diseases, that will be go on the domain of heart disease. So that's what our model is doing. Can we have third slide please? So yeah, that's our system development phases, how we are developing those algorithms. The first is audio input via Gemini API. So we are using Gemini API, which is an open source. Whenever a communication is happening between a doctor and patient, those speech is transcribed in the form of words using Gemini APIs. Second is we are doing text processing using NLP. So NLP is natural language processing. So what we are doing is we are using those transcription thing into naturally transcripted data, like human friendly data. Then third is future engineering. We are using those keywords to match, like heart disease will be matched with those keywords. The fourth is model interference with TensorFlow. I am not a data scientist, I don't know Python, but I know JavaScript well, so that I can use TensorFlow to match those data sets. Is it relevant data set or not? The fifth is output and visualization. A doctor can visualize that prescription thing that is generated in those prescription is relevant or not. Like a doctor is, the communication has happened and then the doctor is rechecking those prescriptions. Like in the disease section, is that all relevant keyword is extracted or not? In the symptoms section, all those relevant keyword are extracted or not, and they can automatically, manually also can do that. like if any relevant thing is not generated. So for using TensorFlow, there is a thing that it yields regenerative things is also there, like regeneration model is also in the TensorFlow. So you don't need to write algorithms for that. You just you need to add another layer in those algorithms. That's the unique approach we are doing. Next slide, please. So that's our algorithm enhancement, how we are training those models. The first thing is we are using NLP plus TensorFlow. That's the unique approach we are doing. The second, and in that approach, the tokenization and leximization is also doing. So that's the first part we are doing. Next slide, please. The second part is model calculation and browser extension. So model is trained. How do a web developer or a React Native developer or any mobile developer can use those models in their personal project? So we deployed those models for open source, so anyone can use and just an endpoint for an API and use in their personal projects also. So that's we are doing. Next slide, please. So that's the future scope. The another layer that we will be developing. The first is symptom checker. The second is medical text summarizer and tone thing, and a smart healthcare bot. So think of a situation where you have a prescription, like you go to a doctor and then you get a prescription. Then if you want to communicate with that PDF, like is that symptom is more severe or not? Do I will recover in a short mean time or not? Those kind of questions you can't do with a hard-coded prescription. So in our model, that's what we are developing, you can communicate with those prescriptions. That how much time we will get to evolve and how much time we will be, the disease will be treated. So that's what we are doing. The next slide, please. So these are the benefits. First benefit is the automatic clinical flow. Second is the smart documentation. We are doing smart documentations, like you don't have to manually write those prescriptions. Third is it gives you a real-time insights. Like if you are not from a medical background, you can still find those relevant keywords and understand that prescription better than a manual prescription from a doctor, handwritten prescription. And it also gives you organized records in your mail. We are using node mailer also, so that you can get those prescriptions in your mail and in your section as well when you log into that platform. And it also reduces time, like you don't have to go for manually prescription for a medical shop or anywhere else. So that's our benefit. Next slide, please. So that's the conclusion. If you are not a data scientist, you can use TensorFlow plus NLP and those three layers in your personal project. You don't need to be a data scientist or someone who knows Python well. It enhances healthcare, and for a doctor, there is a easy to do business. Like you can manage it in your small clinical workflow also. So you can manage it very well without need for much person to manage your workflow. You can use AI for that, and it reduces manual workload. So as AI is emerging, AI is developing, why the most important thing in our life, the doctors will be fall apart from using those AI. So we are giving that solution so that the doctor also can use those models and AI for prescription generation and using NLP also. So that's our vision. Next slide. So these are references we have done from our research projects. Those references are from IEEE conferences, Harvard University's papers, published papers, and IIT's published papers. Renowned scientists from IIT Roorkee, we had communication with them for their workflow. So that's our vision. Next slide. Thank you very much, and thank you Dr. Pradeep Jha sir for giving us stage to showcase our work, and Manju ma'am to help me throughout the journey, and respected our beloved speakers for coming into our college and giving us your time. Thank you so much, sir. so much, authors, for your presentation. Now I would like to announce that post lunch we have 6 segments. For the segment 1, which will be held in this order, we have session chair Dr. Ravi Shankar Sharma, Miss Manju Mathur, Mr. Hemant Mittal, Mr. Pankaj Jain. The papers to be presented in this order will be paper ID 109, 117, 126, 133, 114 and 127.
For the segment 2, the venue is LH41. For this, we have session chair Dr. Ruchir Saxena, Mr. Amit Bohra, Ms. Kritika Paliwal, Ms. Kritika Rohila. And the paper IDs to be presented are 102, 104, 105, 106, 107, 108, 110, 111, 112.
And the third segment will be held in LH44, and that has the session chair of Dr. Sangeeta Soni, Mr. Santosh Kumar and Mr. Manish Jha. And the paper IDs to be presented there are 113, 115, 116, 118, 119, 120, 121 and 122.
For the segment 4, the venue is LH45. The session chair are Dr. Garima Nahar, Ms. Apurva Joshi, Ms. Archana Dubey. And the paper IDs to be presented are 123, 124, 125, 128, 129, 130, 131 and 132.
For the fifth segment, we have the venue of Electrical Engineering Seminar Hall, which has the session chair of Dr. Ravindra Singh Maan, Ms. Anantika Johri, Mr. Dharamveer Jagir, Mr. Vikram, Mr. Abhay Purohit sir. And the paper IDs to be presented there are 134, 135, 136, 137, 138, 139, 140, 141 and 142.
For the segment 6, the venue is 5201. The session chair are Mr. Chandrabhan Mishra, Ms. Ayushi Shukla, Mr. Lakshmikant Vashish, and the paper IDs to be presented are 143, 145, 146, 148, 149, 150, 151, 152 and 153.
All of you have to be back before 1:40 to the respective venues.
Thank you.
If anybody has any doubts regarding their paper number and venue, they can contact me at the stage.